Hello, Christoph. Christoph, you are the head of data science and artificial intelligence department at the Fraunhofer Institute for Applied Information Technology. You are also a senior researcher at Aachen University. And I think I can say that thanks to this experience in those roles, you have been one of the leading roles in through GAIA-X and IDSA, the International Data Space Association, to actually implement or to create the information model for IDSA RAM, and also in some of the exercises and working groups that are ongoing around the Data Space Support Center. So, Christoph, from those different involvements in the initiatives that I've mentioned related to the data space, what's your take on the main challenges that the data spaces face when it comes to interoperability?
So first of all, I think we should acknowledge and appreciate the level of interoperability that's already been achieved. So when it comes to establishing trust among participants, organizations who have not known each other before, that already works well. Also, when it comes to one participant in a data space finding out what data, what services are being offered by other participants, and when it comes to the actual data exchange. These work well. However, looking at this current state of the art, there are limitations. One limitation is that it only works really well within one data space, so it's not yet fully understood and to a small extent only implemented how to do that across data spaces. Then secondly, when you build your one data space, currently you have to make an early decision for one architecture and one stack of technology. So for example, IDS versus GAIA-X versus FiWare. Will take some time for these to harmonize and grow together. And the third limitation is that the basic communication protocols and information metadata models, they are well understood and supported, but they do not yet incorporate domain-specific semantics.
Interesting. But then for those two challenges or key challenges that you mentioned, related, for example, to the building blocks, technical building blocks that FiWare, IDSA, and GAIA-X have built on their respective sides, or together sometimes also, but also the information and data models level. What's the role you see for SEMIC to actually support and reach that interoperability level within data space and across data spaces?
I think where there is still a way to go is to foster a deeper understanding of the common underlying standards. So for example, it is widely understood and accepted that JSON as a structured data model should be a foundation, that we also need explicit semantics. So in other words, JSON LD, it is also understood that we need to talk about data and service offerings in terms of the data catalog vocabulary DCAT and DCAT AP. Okay, but then we are reaching the limits of like broad knowledge that is in the minds of domain experts building data spaces. So there are many actors who do not know or who have not fully realized what the LD in JSON LD means, so that it stands for linked data, the W3C, like linked data principles, or what's also related is the 5-star open data principles or the fair data principles. These principles and the tools that technically implement them, these still require a deeper understanding to be built through education and through the provision of tools. That's a thing that SEMIC could do, and the same holds for DCAT AP, one of the flagship products of SEMIC. I think there is more to it than just saying, okay, here we have taken the W3C data catalog standard and we've made it a bit more suitable for the public sector in Europe, but this application profile mechanism, which is what AP stands for, this can be used for a lot more things in enabling interoperability in data spaces by refining the basic metadata models and communication protocols to take into account domain-specific semantics and expertise that is represented in ontologies.
Interesting. And from that perspective, what's your take on the synergies between SEMIC and the Data Space Support Center, DSSC, to actually achieve this?
Let me explain that in the context of the primary product that the Data Spaces Support Center has recently delivered and of which new iterations are scheduled for delivery. That is the Data Spaces Blueprint. Recently, we've seen the release of version 2.5 of the blueprint that comprises a harmonized glossary of data space terms, a unified conceptual model, and now, more importantly, building blocks. Building blocks, for example, a building block on data and services offerings. How to describe these? This relates to our topics of discussion on the metadata level. It ensures interoperability on the metadata level, and a second building block closely related to SEMIC is the building block on data models. So talking about the content and the semantics of the data that is being exchanged in the data space. And for both, in the definitions of both building blocks, SEMIC artifacts and outputs such as DCAT IP have already been adopted. But initially, it is currently on a high level. It was the first public release of this blueprint, and now that every half a year an iterated and improved version is going to be produced. Like version 1.0 is scheduled for March. There are ways to get involved, to have your say, to influence not how things are invented, because we are not inventing new things, but how things are explained, what recommendations are given, and that's one good way of getting involved is to become an expert in the expert groups that are responsible for these individual building blocks.
And from that angle, would you gave an example with DCAT AP. Would you see some of the other current SEMIC solutions and assets, or some of the ones such as in AI, in which SEMIC is looking, for example, with the link between AI and interoperability on? Or in other words, how AI could support different use cases related to interoperability, to map ontologies, to create new terms within an ontology, and so on. So do you see also this kind of things as potential aspects in which SEMIC could support? And I will give maybe two concrete examples. LDES is, I believe, something that could be interesting for the data spaces. Also the tooling aspect, where SEMIC has some experience related to semantic tooling, registry of vocabularies, and so on. Are those also areas in concrete assets and solutions in which you see potential collaboration between SEMIC and the data spaces?
The short answer is yes, of course. Input on these SEMIC products is definitely welcome. For example, looking at LDES, linked data event streams, that is something that could be relevant on two levels of data spaces. On the one hand, when I provide data and this data changes and gets updated, then I might want to equip it with an LDES interface and saying in my data service description, I might want to say, okay, you can access my data offering in conformance with the LDES specification, but also on the level of data space infrastructure. For example, synchronizing the repositories with information about data and service offerings between multiple catalogs. For that, LDES could also be a useful synchronization protocol. That was about LDES and tools like intelligent tools for creating or managing, well, even the whole life cycle of ontologies. They are also most welcome. So there is in the data space terminology is that there is the term of vocabulary hub, and that is we we've seen this when looking at state-of-the-art solutions. There is a lot of potential in building. So using a version controlled repository as the technical basis, and then building intelligent validation up to analytics tools on top of that to enable a group of domain experts to build a high quality ontology.
Yeah. Thank you. That was very interesting, and that brings clear perspectives for SEMIC to contribute with all the actors that are acting around the data spaces. Thank you, Christoph.
Thank you.